Section 6.4, mixed operations. That means we're going to be doing adding, subtracting, multiplying, and dividing in the same questions. So we need to make sure we're following BEDMAS. Remember, B is brackets, so you do the stuff inside the brackets first, then the exponents, then division and multiplication together, addition and subtraction together. 1b, simplify. 4 over 2x cubed minus 5x plus 10 over x to the 8th divided by x plus 2 over x cubed. There aren't any brackets, and we don't have exponents that we need to distribute, so we're doing division and multiplication. Noticing I have a divide by sign there, so I'm going to have to use my fraction rule, where if I have a divide by sign, I now change that to a multiplication and take the inverse of the second fraction. I'm going to just copy down the first two fractions I hear, change my divide by sign to a multiply, and the fraction after that I will take the inverse. Now I can multiply those two fractions together. I cannot subtract yet. Subtracting is the last thing I'm going to be doing here. And I'm noticing I have x cubed divided by x to the 8th. When I am reducing, I would be subtracting those exponents. So, or I can think of it as murderous math. So I have 3 x's up here, and they're going to kill 3 of these x's. So 8 minus 3 is 5. I'm going to have 8 to the x to the 5. I'm also noticing I have an x plus 2, and that's so similar to that 5x plus 10. I'm wondering if I can factor that 5x plus 10. I can factor out a 5, so it becomes 5 times x plus 2. Let's rewrite this. And yes, my x plus 2's can reduce. What I'm trying to do here is to make it as simple as possible so that I really have less math I have to do. Okay, I'm going to rewrite it. That looks a lot simpler. I need to find my lowest common denominator because I'm subtracting fractions now. So I will need to have a 2 in the denominator, an x cubed. Oh, x to the 5th is bigger, so I will need x to the 5th. So my lowest common denominator is going to be 2x to the 5th, which means the first fraction I need to multiply by x squared over x squared. My second fraction I have to multiply by 2 over 2. Okay, both fractions are now going to be 2x to the 5th. And now I can subtract them. I think I can factor a 2 out of the numerator. And now I can reduce the 2. 2 divided by 2 equals 1, which means I have 2x squared minus 5 over x to the 5th. 1d, more simplifying. Again, remember we're doing BEDMAS, and this time we have brackets. So we're going to do the stuff inside the brackets first. So that's going to be this part here. And inside these brackets, I don't have any exponents to distribute. I do have division in terms of fractions, but I'm going to just leave the fractions as is right now. I need to add or subtract these fractions, in this case subtract. And I'm noticing my denominators, I have x squared minus 16 and 16 minus x squared. It would be nice if they were the same, because if they were the same, I already have the lowest common denominator. I want to change this to x squared minus 16, and to do that, I'm going to factor out a negative 1. So it's going to give me negative 16 plus x squared. If I multiply this through, I have -1 times -16, which is 16. -1 times positive x squared is negative x squared. So these two things are the same. And then now I can just rearrange the stuff inside the brackets. So it is x squared minus 16, which is what I want. Now I'm going to move that back into my fraction. Yes, I'm writing everything down because I don't want to lose any parts of my question. Right here, I have negative and a negative together. So if I'm multiplying or dividing two negatives, it becomes a positive. My denominators are the same. So my lowest common denominator, if you want to write it out, is x squared minus 16. And now I can add those two fractions. I'm going to simplify the numerator of that one fraction. X plus x is 2x. 7 minus 1 is 6. And now I can multiply. In multiplying, I could FOIL everything, but I don't want to if I don't have to. So I'm going to see if there's anything that can be reduced. I'm noticing I have x squared minus 16 divided by x squared minus 16, and that equals 1. I now have 2x plus 6 over 2. In my numerator, I can factor out a 2, and now those 2's can reduce. 2 divided by 2 equals 1. So I get a really nice answer for this complicated question. So your answer will be x plus 3. For those savvy students who look in the back and realize that this isn't the answer that's in the back, there is a reason for that. It's because I wrote down the wrong number here. It's supposed to be a minus, an x minus 7. Everything is correct in here. That's the reason why it would be a slightly different answer, but it is the process that is important for these questions. 2h. We're still simplifying, and we have fractions of fractions. This is when you slightly scream in your head. Okay, so fractions by themselves are difficult enough. Now we have fractions of fractions. I'm going to first try to make this into a normal looking fraction with just one line. And I will be doing this by dealing with the numerator and the denominator separately. Okay, so I'm looking at my numerator. I have x squared, xy, y squared. I don't have any brackets, don't have any exponents. So I'm doing my multiplication division, but I can't yet. I have to add and subtract these fractions. So I'm looking for a lowest common denominator. Well, that would be x squared. They'll need an x squared. They all will need y squared is the biggest one. So my lowest common denominator for my numerator is x squared, y squared. My first fraction needs to have a y squared in the denominator. Second one needs both x and y, but just one of each. And my third one needs an x squared in the denominator. So I have 4y squared over, oops, I forgot my square there, x squared, y squared, minus 12xy over x squared, y squared, plus 9x squared over x squared, y squared. I'm just going to put my fraction line here. I'm going to leave the denominator for a moment, and I'm going to simplify the numerator because I can add and subtract these now. Okay, that looks a little bit simpler. All right, now let's do the denominator a little bit. So my lowest common denominator for my numerator is going to be, oh nicely, x squared, y squared. I like that because it's the same as the numerator. So first fraction, we need a y squared. Second fraction, we need an x squared. So we're going to get 4y squared over x squared, y squared, minus 9x squared over x squared, y squared. We can subtract. And actually, I like it that of the little fractions, they both have the denominator of x squared y squared because I can do something really neat to get rid of those fractions. I'm going to multiply both the top and bottom by x squared y squared over 1. And I can do that because it's the same thing. It's like 5 over 5 equals 1. I'm writing this specifically as a fraction like this, so it's easy for me to see what's going on. So x squared times y squared divided by x squared y squared equals 1. This one, we have x squared y squared divided by x squared y squared equals 1. Now I have 4y squared minus 12xy plus 9x squared over 4y squared minus 9x squared. I've gotten rid of the fractions of fractions. I just have one fraction and now it doesn't look nearly as bad. We're not finished though, so let's see if we can factor the numerator. I'm going to use the box method. Again, remember there's a few methods to use here. Okay, so I get 2y minus 3x times 2y minus 3x. And my denominator is 4y squared minus 9x squared, which is the difference of squares. Switch the sign for the difference of squares. And I analyze this, and I'm noticing I have 2y minus 3x divided by 2y minus 3x, so I can reduce that. That will equal 1. And my answer is 2y minus 3x over 2y plus 3x. We're still on question 2. 2n. Again, we have fractions of fractions. X plus 2 over x plus 3, all over x minus 5 plus 12 over x plus 3. There are two ways we can do this. We could try to get rid of the fractions of fractions first, or we can put everything over the common denominator and then get rid of the common denominator. Well, in the previous question, I got a common denominator for everything, so I'm going to do this one a different method. Let's just multiply everything by x plus 3 over 1 over x plus 3 over 1. So rather than finding a common denominator, which is another way to do it, which is what we did in the last question, I'm just going to multiply this through. And I can do this because I have x plus 3 over 1 divided by x plus 3 over 1. That equals 1. So I have to remember to FOIL while I'm doing this. So I'm going to have x times x plus 3 plus 2 times x plus 3 over x plus 3. I'm going to use little n's on this line so I remember which is my big fraction. X times x plus 3 minus 5 times x plus 3 plus 12 times x plus 3, a bit longer, over x plus 3. I'm going to reduce x plus 3 divided by x plus 3 equals 1. X plus 3 divided by x plus 3 equals 1. And now I have x times x plus 3 plus 2 over. It is very tempting to reduce this x times x plus 3 and this x times x plus 3, but you cannot. The reason why is they're being added and reducing is dividing. So let's multiply everything through and get rid of the brackets. Let's factor the numerator. Two numbers that multiply to 2, which add to 3. And let's factor the denominator. Two numbers that add to negative 2 that also multiply to negative 3. Okay, I'm going to analyze those. I can reduce. X plus 1 divided by x plus 1 is 1. So now I have x plus 2 over x minus 3. Still on question 2. S, x over x plus 1 plus 3 all over x plus 1 plus 3 over x plus 1. We don't just have fractions of fractions, we have fractions of fractions of fractions. Oh my! Okay, so what are we going to do here? How about we get rid of the fractions of fractions of fractions? I am going to, first of all, I like marking where my main fraction is so I don't lose track of that. I'm going to just remind myself that this is really over 1. And I'm going to be focusing at first on the denominator. So I'm going to rewrite the denominator over here. I'm going to see if I can make it a little bit simpler so it'll be easier for me to see what's going on here. So if I write it this way and I look at that, and if that's my main fraction line, I can multiply both of these fractions by x plus 1 over x plus 1. Now, we could make these fractions into fractions of fractions, and then that would be x plus 1 over 1. So just to help you see what's going on, I could put an over 1 in both of these and in both of these. I know right now it's making it look more complicated, but it'll help. And now my first term here, I have x times x plus 1 over x plus 1 times x plus 1. And this x plus 1 will reduce that x plus 1. So it equals 1. So now I just have it over x. That does look a lot nicer. So I'm going to put that into my main fraction. Let's put them all together now. All right, so let's look at this. We need a lowest common denominator because we're going to be adding fractions. So if I look at my denominator at the bottom of my denominator, I have x times x plus 1 times x plus 1. I could make that for my numerator as well. And in that case, it'll be easier for me to reduce things later. So I'm going to just put brackets around this guy. Going to need an x times x plus 1 here. It has to equal 1, so I need to do it to the top and bottom. This one will be x times x plus 1 times x plus 1 over the same thing. I realize that this is a little redundant, but you have to make sure you write everything down so you don't forget something. And it's usually the little things that will get you at this stage. So my numerator of my big fraction is my big fraction line. My denominator of the top is going to be x times x plus 1. My numerator of the top, we have x times x plus 1 plus 3 times x plus 1. There are a lot of x plus 1s everywhere here. Okay, so with my main fraction, I'm going to multiply the top by x times x plus 1 times x plus 1 over 1 divided by x times x plus 1 times x plus 1 over 1. This x will reduce that x plus 1 reduces this x plus 1, this x plus 1 reduces that x plus 1, this x reduces this x plus 1 reduces x plus 1, x plus 1 reduces x plus 1. So x times x, I will multiply those two together, so x squared times x plus 1 plus 3x. I don't want to multiply these out if I don't have to. Okay, let's see. Everything has an x plus 1, so I'm going to factor out an x plus 1 from the top. And I can factor out an x plus 1 in the denominator. And x plus 1 divided by x plus 1 equals 1. So this can be reduced. So I'm going to rewrite this, multiply out my brackets. 3x times x is 3x squared. 3x times 1 is 3x. X plus 1 times x plus 1, remember to FOIL it. Let's just simplify. And I could factor an x out of the numerator, but I can't do that out of the denominator, so I won't be able to reduce it anymore. And this will be your final answer. 3D. Simplify each complex fraction. X to the minus 1 minus y to the minus 1 to the minus 2. We have lots of exponents here. Again, remember we're doing BEDMAS, B brackets. No, we can deal with the exponents inside the brackets first. So remember the negative exponent means you take the inverse. Okay, so we need to finish what's inside the brackets first. So we have to subtract these two fractions. In order to do that, we need to have a lowest common denominator. So the lowest common denominator is going to be xy. So we need to multiply the first term by y over y and the second term by x over x. So we have y over xy minus x over xy. Don't forget to copy everything else down. Y minus x over xy. Now we can deal with this exponent here because everything inside the bracket is done. So let's take the inverse and we'll square it. So we're multiplying fractions, you multiply the top. So x times x is x squared, y times y is y squared. Y minus x times y minus x, we simplify. So we can write this down as y minus x squared.